Welcome to PreMath. In this video, we have got this blue square ABCD fully inscribed in a circle with the center O, as you can see in this diagram, such that the area of this blue square has been given to us as 338 square units. And now our task is to calculate the area of this green shaded region, this area and this area combined. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our action plan. And since we are dealing with this circle with the center O, so therefore our very first task is to calculate the radius of this given circle. And now let's assume the side length of this blue square is x. Since all the sides of the square are equal, then this side is going to be x, x, and x across the board. And now let's recall the area of a square formula, area equal to s square, where s represents the side length of the square. And in our case, the area of this blue square has been given to us as 338, and the side length of this blue square is x. So therefore we can write down x square equal to 338. Let me take the square root on both sides to undo this square. And now we can see this square and square root undo each other. So therefore x value, when we simplify the right hand side, is going to give us 13 times the square root of 2. So therefore our x value turns out to be 13 times square root of 2. So therefore this side is going to be 13 times square root of 2, 13 times square root of 2, 13 times square root of 2, and likewise 13 times square root of 2 units. And here's our next step. Let me go ahead and connect these vertices A and C. As you can see in this next step, we can see this AC is the diagonal of this square. And since we are dealing with this blue square, so that means all these interior angles are going to be 90 degrees each. And now let's focus on this right triangle ABC, whose side lengths are 13 times square root of 2, 13 times square root of 2, and this side AC is unknown. So therefore we are going to apply the Pythagorean theorem to calculate this side AC. And here's our Pythagorean theorem: a square plus b square equal to c square. Let me label this longest leg, the hypotenuse, as lowercase c. I'm going to label this side lowercase a and this lowercase b. Let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is 13 times square root of 2 whole square plus likewise 13 times square root of 2 whole square equal to c square. Let's simplify. This is going to give us 338 plus 338 equal to c square. Let's go ahead and undo this square by taking a square root on both sides. And here we can see square and square root undo each other. So therefore our c value turns out to be 26. So therefore our c value turns out to be 26 units. And now let's make an observation. We can see that this diagonal AC is the diameter of this circle. So therefore diameter turns out to be 26. And we know diameter is simply twice the radius, equals to 26. Let's divide both sides by 2. This 2 and 2 cancels out. So therefore our radius of this circle turns out to be 13 units. Before we proceed any further, let me go over the basic review. And now let's focus on this blue square. And here in this next step, I have constructed this red triangle whose base is same as the side length of this square. And likewise, the height of this triangle is same as the side length of this square as well. Then we can see the area of this red triangle is going to be equal to the sum of these two outside triangles. As you can see in this equation, A equals to A sub 1 plus A sub 2. And now we know that the area of this whole blue square is 338. So therefore we can see that the area of this white triangle is going to be half of this square area. So this area is going to be 169. And likewise, the other half of this square is going to be 169 area as well. This area plus this area is 169. And here's our next step. Let's focus on this diagonal of this square. Then this diagonal is going to divide the area of this whole circle into two equal parts. If this area is star, then this area is going to be star as well. And likewise, I have drawn another diagonal, and that divides likewise this area of this square into two equal parts, this part and this part. Therefore, we conclude that these two diagonals divide the area of this blue circle into four equal parts. And if the area of this triangle is A, then the area of this other triangle is going to be A as well. And likewise, this area is going to be uppercase A, and finally this area is going to be A as well. Let's assume the square area is 4. Then the area of this triangle is going to be 1, 1, 1, and 1. And likewise, all these angles are going to be 90 degrees each. So therefore, we can transform this area of this square in this form. And the area of this whole shaded region is going to be 169 as well. And furthermore, this angle is 90 degrees, and likewise this angle is 90 degrees as well. So therefore we conclude that this whole green region area turns out to be this quarter circle area plus this whole quarter circle area, as you can see in this equation. And now we can see 2 times the quarter circle area is same as the semicircle area. And now let's recall the area of a circle formula. Area equals to pi r square, where r is the radius. So therefore the area of the semicircle is going to be pi r square divided by 2. And in our case, our radius r is 13. So therefore this green region area is going to be simply pi divided by 2 times our radius r is 13 whole square. So therefore if we simplify the right hand side, that is going to give us 169 pi divided by 2 square units. So thus the area of this green shaded region turns out to be 169 pi divided by 2 square units. And that is going to be equal to approximately 265.5 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.